Vesicular Stomatitis Virus. So I have 6 slides. The first slide, this one, and then slides 4, 5, and 6 come back to VSV. Okay, I'll spare you the Vesicular Stomatitis Virus. I'll come back to VSV. But slides 2 and 3, I want to step back from this. This is a specific problem. It's an important problem. Is it a major, huge problem? No. We don't care at the moment. It is a problem, though. This is an issue. We'll talk about it. But slides 2 and 3, I want to step back from this and talk about what addressing this problem means and how to go about it. And it can be a template for really expanding how we think about science and what we should be doing. All right. This is a particular virus carried by several vectors, but in particular this beast, sandflies. Sandflies are nasty little critters around the globe. They carry lots of, you know this, you've been around the globe, carry lots of different viruses, and many of them actually are quite harmful to humans. In this particular case, this rhabdovirus, which is rabies-like virus, is not really particularly harmful to humans at all, but it has a huge impact. It's not fatal, but it has a huge impact on cattle and horses and some other livestock, but you really see it with horses and cattle. And so when this character bites those animals and transfers that virus, very quickly you'll see blisters and lesions in the mouth and nose. You'll see lameness and, of course, loss of production. It really causes the animal to suffer. It will not kill them. It will pass in about 30 days. But it is a reportable disease. And what that means is if you have that issue here in southern New Mexico with your horse, you have to tell a brand inspector or APHIS that you have this issue, because it will lead to a quarantine. One of the biggest impacts of VSV is shutting down the ability to move and or sell animals because they're infected with this virus. And so we'd like to have a better idea about this virus. A lot is known about this critter, and a lot is known about the virus. It is endemic to the Western Hemisphere, and actually primarily also in North America, but Central and South America. It's not here every year. So that vector, principally the sandfly, has to move north, and they typically come up water courses, Rio Grande River, right? And there's been several outbreaks in recent years. The outbreaks then often create and can shut down the horse racing industry for periods of time. If those horses are infected, you can't then move a horse from one track to another, for example. Same with livestock. Or you've got to find a way around the counties that have been quarantined. Here's the problem. Early detection of conditions suitable for an outbreak and early signs of an outbreak, especially here in southern New Mexico along the Rio Grande, would be extremely useful in limiting impacts on animal health. If we really knew and sent out an alert, we really expect to see these characters moving in and then dealing with that. And you can deal with, there's various ways to deal with that. But that's really the problem. Now, it's not as serious as foot and mouth, when we're going to end up burying animals in order to limit disease transmission. The animals aren't generally going to die off. But it still is a reportable problem we've got to pay attention to. Okay. There's VSV introduction. Next slide, please. All right. I said slides 2 and 3, we're going to step back. At meetings, workshops I've attended with ARS administration in recent months, often you see this image or an image like it. Now, that does not mean that ARS is opposed to farm silos. What they're talking about is, what they are opposed is us as scientists staying in with our silo of knowledge. And they're doing everything they can to try to break us out of that. Now, let me give you some examples of what's happened over time. When I first started here, and of course, that was a long time ago, and some of the youngsters here ask me, were there dinosaurs? I typically say, not yet. it became later.
We barely had dirt.
Yeah, I had to get that. Let me give you an example of what they've done very quietly, ARS administration. About 20 years ago, ARS, with between 1,800 and 2,000 scientists and postdocs, had over 1,300 individual research projects. So people would write a 5-year project plan that would cover themselves and maybe one other person, right? And they would work on those objectives and publish and succeed, right within whatever small little subject area that might have been. Very academic, right? We've all come out of academic environments. ARS realized that, sometimes that led to phenomenal breakthroughs, of course, but really addressing large national problems, maybe not so effective, to be that narrow. And they've slowly, without saying much, they've whittled away at this. Today, ARS has about 750 individual research projects across 17 different national programs. One national program is Rangeland Science Pasture and Gorges. One is post-harvest activity. Post-harvest utilization. I knew there was a third word. So the cotton gin is post-harvest utilization kind of national program. 750 projects, so not quite almost in half in these different categories. And still there's about 1,800 to 2,000 scientists and postdocs. The intent of the administration, it's not publicized, but I know for a fact the intent is in the next even 5 years, there'll be 600 projects, still with the same, if not a few more scientists and postdocs. They're starting to narrow this down. And in fact, I think in the next 5 to 10 years, you are not going to see national programs like range science, like post-harvest utilization. What you're going to see are, next slide please, you're going to see a whole series, you're going to see 5 or 6 grand challenges. Last July, the ARS asked me to organize a workshop to develop the first grand challenge. Most of the people were invited, that was somewhat political, but scientists mostly. I was able to invite Deb, she graciously agreed to attend. And we spent 3 days yelling and shouting. And at the start, most of us were kind of down trying to organize the grand challenge around our particular interests. But after a little while of kind of talking about that, we finally got our head around what it is we were trying to do, and we developed this grand challenge, right? So Sherry mentioned it. We call it 20 by 20 by 2025. Right? 20% increase in quality production, 20% decrease in environmental impacts by 2025. You can look at this literally and be quite cynical. How are we going to do this? How are we going to measure this? I would encourage you, because I think this is where the agency's going. There's going to be another workshop soon for another grand challenge and a few more after. And they're going to have people back at headquarters that help coordinate these, and then they're going to have leadership in the field to help coordinate all of the activities associated with different goals that contribute to this. And this is, the agency then will distinguish itself from an ag experiment station or other kinds of activities. And really, this is their version of a moonshot. Go send somebody to the moon, hopefully bring them back. All right? Now, within that, there are a whole series of goals. The intent of this goal, for example, decrease impact of emerging pest pathogens and invasive species that threaten U.S. agriculture. VSV, right? That's VSV, as an example, right? The intent, though, is not for this particular goal to stay within the context of the virologists and the veterinarians. The intent is for the science that addresses this problem to be much more expansive. Recently, Joanne and I attended a conference in Fort Collins, and a fellow was talking about trying to work out of his silo, right? He said, I started by meeting with some people in a bar in Miles City, and there was a range scientist, an animal scientist, and an agronomist. And I thought, this sounds like a really bad joke. They walked into the bar, and bartender looked up and said, why the long faces? But, that's a start. That is a start. But that's not the bar we're thinking about. Okay? That's not. That's a good start. The bar we're thinking about, the bar that we really think is needed to do this, is the bar in the first Star Wars movie. That bar. Maybe without the bounty hunters and the lightsabers and a few other things. But where you walk into a bar and you're really not sure who might be there, and you have conversations and look for opportunities. A lot of times, research organizations, universities, try to force this, right? They create research clusters, right? You put these people together. But if there's no problem, people wonder why they're together. You can't find a problem. So at this July workshop, we had a bit of a Star Wars bar scene. Okay? Deb started talking with various people that she normally hasn't met at, and she has other connections now through working back in DC, that starts talking with other people and start learning what are the kinds of issues they needed to address. Okay? Taking this idea and expanding out of our comfort zones, making new science connections to build a new knowledge base. So, working hypothesis of the origin, you've got infected cattle, primarily also horses, mostly in Mexico. All right, the vector moves north. We'd like to know the conditions under which it is urged to move north. The vector can infect other vectors, hence this circle, and then moves on up into the United States, usually along water courses. And you can find it in Idaho. So, building the team. What do you need to really look at this appropriately, at least as a start? Next slide. All right, first, you need the virologists. You need the people that understand the virus and what are we dealing with. So when the virus ends up here, really, where exactly did that virus come from? Because there's lots of different kinds of virus. And so we're seeing really nice work now being done through Mexico that's indicating where that virus has come. The ARS National Animal Disease Lab, genetics of where the infected animals are coming from. Then you have APHIS. So when you have a reportable disease and you report through the channels and it gets up to APHIS, APHIS is producing information like this when you have an infection. And so you can call up and see, hey, we've got VSV in these areas right now, and we may have a quarantine issue that'll shut down the movement and the sale of animals. That's part of the team, part of the database. Then there's got to be the arthropod-borne animal disease people, the vets, right? These are the people that really deal with what is the extent of the impact. All right, how long are these animals being impacted? And there's the Jornada. Another part of the Star Wars bar scene. Ecological, hydrological, and climatological conditions underlying the spread of the disease. Makes perfect sense. These are not people we would have normally worked with. But now we got a problem. We had a setting that allowed us to work outside our comfort zone because of Deb looking for talking to these people and starting to see some connection. Palantir is a company, and you'll see where in a minute, the data integration. All right, so there's our band in the Star Wars bar. Right? Not one, we would have, if you had asked me a couple years ago, do you think you're going to be working on VSV with virologists from New York and data integrators from California? What? But this makes huge, huge sense. All right, let's look a little bit closer. So right now the ARS, the national program, and Deb's been more specifically than working with these people, are thinking about this project as a pilot grant challenge. Is this going to increase production by 20% and reduce environmental impact by 20%? No. But the idea as a pilot project is moving us in that direction to think about this. So let's take a look at the players, the band members. So Luis Rodriguez, a virologist. He's amazing. He knows a tremendous amount about this virus. But that knowledge is pretty much limited to that particular subject. And he's at Plum Island in New York. Next two clicks, please. Scott McVeigh. Scott McVeigh is in Manhattan, Kansas, and he's a vet. Next two clicks, please. Deb Peters, and she's enlisted Emily Elias. She sneakily enlisted me today. I agree. But we've got to understand, as she mentioned, the ecology and the climate and the hydrology, right? So involved here, and then we have, next two clicks, we've got APHIS, Angela McCluskey, who's based in Fort Collins, and there'll be a meeting then in Fort Collins in early June with the last band member, Chip Emanuel, with Palantir Technologies, who is actually doing this for free. They want to see what this project's really going to look like. So a lot of the data sources, a lot of the information underneath this is going to come from these players and APHIS, and then asking these folks to step in. And ARS is starting to pony up a little bit of money to help us with this effort. And then the last slide, please. So here's the proposal. We know it's a complex arthropod-borne disease, and the occurrence seems to be influenced by both abiotic and biotic determinants. So we want to look at that and understand that. Emerging vector, actually I think there's one more slide. Emerging vector-borne diseases are especially important because of their high frequency and emergence, their economic impact, etc. This is the point I want to get to, though. A national research program in predictive biology is needed to integrate ARS core competencies in infectious diseases, microbial and host genomics, entomology, ecology, disease detection, and epidemiology. Okay, you got to have all those disciplines to start getting at this particular problem. And actually, Jim, if you could go back a slide. Yeah, this is what I was looking for. So, originally, Luis, a couple years ago, these are his two objectives, right? And he's working on the virus. And one of the objectives that I've underlined, ascertain the viral ecology of disease and factors mediating the reemergence of VSV in the US. Great. But how do you mediate the reemergence if you don't understand the conditions under which it emerges? Right? You need those predictions. So I think once he started making connections with Deb and they started talking about what we might be able to do as a research group, it became more evident to him that he needed a wider set of connections to address this particular problem. I'll go back to that last slide. So I mentioned at the start, we think, this isn't a huge problem, right? An animal will get through it generally. It creates inconvenience, it creates economic loss, it creates animal health problems, and you hate to see that. What we're trying to do, though, with an emphasis on new connections and predictive biology, is then think about a model that can have application. What are we fighting more and more these days? More and more, we're fighting these kinds of spreads of viruses and things like Zika. All right? Can we use these ideas to help us move in new directions? This group, over the years, has been really good. If I think back to where we were when dinosaurs were here, and putting fecal bags on dinosaurs, and estimating dinosaur carrying capacities on the ranch, and dietary intake. And we lost a few good technicians. But the good thing, the benefits were good for their family. Back in those days, those kinds of studies were important. But we learned, as we thought about new connections and new ideas, and thinking about monitoring and assessment, and understanding land potential and land status, it really started to take us in new directions. And I think for this place, you're in a good spot now, but don't stand still. Don't. Keep looking for these new connections. Keep looking for ways to contribute. This is why we joined LTAR. The money helped. But at first there was no money. This is why we joined the Climate Hub. The Secretary of Ag told us there will be no new money. Well, they weakened. But we didn't join for the money. We joined for the connections. And I swear those have been we wouldn't have this idea, this common experiment, which is, I think, brilliant. You can compare a range livestock system in southern New Mexico, to a wheat farm in Washington, to a dairy farm in Pennsylvania, to a corn farm in Iowa, to a cotton soybean rotation in Georgia. Because everybody could have a business as usual and an aspirational system that may increase production and reduce environmental impacts. We just have to find a way that's kind of a common way for us to measure the responses that we think are common across all of that. That's fantastic. So we've always been looking for new connections. And so you guys are amazing. You've got lots of capacities. Don't stay comfortable. There's great opportunities. You've got people working on as pilot projects, whether it's this, whether it's Criollos, whether it's land PKS, and exhausting projects. They continue to move you out, and you'll be absolutely fine. And that's all a homeless man can say about vesicular stomatitis.